All right, let's dive right into this. Imagine, just for a second, that the universe around us isn't just made of physical stuff like atoms and molecules, but of something way more fundamental, like a hidden language or a secret code. In this explainer, we're going on a totally cinematic journey into the actual architecture of logic itself. We're looking at MTES6012 Introduction to Number Theory. Now, I know what you might be thinking, but trust me, this isn't your standard dry mathematics overview. No way. This is an invitation to uncover the literal blueprint of reality.
So what are the secrets behind numbers? Most of us use them every single day, right? But we never really stop to realize we're handling ancient, mysterious artifacts. The real question is, are you ready to decode them? Are you prepared to step beyond just simple counting and actually understand the invisible structures holding our digital, physical, and theoretical worlds together? If you're a focused learner craving a direct line to that kind of understanding, well, you are exactly in the right place.
Take a look at this official course synopsis. I want you to treat this not just as some syllabus description, but as your personal mission statement. You are going to explore patterns, solve problems involving integer structures, and assess appropriate methods in various numerical contexts. Now, what does that actually mean for you? It means you're building critical cognitive and numeracy skills. You aren't just memorizing formulas here, you are literally training your brain to see connections and solutions that are completely invisible to the untrained eye. It's a real game changer.
Okay, here is the roadmap. The 6 main keys you'll master on this journey. First, the basics of number theory, mystery. Second, the hidden secrets of prime numbers. Third, divisibility and magic squares. Fourth, powerful modular arithmetic applications. Fifth, Euclid's algorithm and Diophantine. And finally, number 6, unraveling irrational number mysteries. Let's jump right into Chapter 1, Basics of Number Theory Mystery.
We're framing these foundational concepts not as dusty textbook math, but as ancient codes just waiting to be cracked. This is where we lay the groundwork, where we learn exactly how numbers interact, how they group together, and how they form the building blocks for absolutely everything else we'll encounter. And you'll learn to manipulate a massive variety of beautiful numerical patterns. We're talking about geometric representations here, like triangular and square numbers, or hexagonal and pentagonal numbers. We'll even dive deep into the legendary Fibonacci numbers. You know, the sequence that literally dictates the spiral of a galaxy and the arrangement of petals on a flower? You'll also explore Pascal's triangular numbers and the incredibly elusive perfect numbers. You'll systematically analyze these sequences and spot the exact same patterns that have fascinated mathematicians for millennia.
Moving on to Chapter 2, Hidden Secrets of Prime Numbers. Now we're plunging into the really elusive stuff, primes. These are basically the atoms of mathematics. They're indivisible, totally unpredictable, and fiercely independent. And honestly, understanding their basic properties and prime factorization isn't just theory. It is the bedrock of modern cybersecurity. Consider Goldbach's conjecture. It states that every even integer greater than 2 can be expressed as the sum of 2 primes. Sounds super simple, right? Well, it remains one of the greatest unsolved mysteries in all of mathematics. In this course, you won't just passively learn history. You are going to actively confront these active mathematical mysteries. You'll apply theorems to solve non-routine, complex problems involving prime and composite numbers. You are stepping onto the absolute frontier of human knowledge here. Up next is Chapter 3, Divisibility and Magic Squares. This is where strict analytical proofs meet pure magic. Take a look at the legendary Srinivasa Ramanujan's birthday magic square. If you add up the rows, the columns, or the diagonals, you get the exact same number, every time. But in MTES6012, you don't just stare at it in amazement. You are going to analytically calculate the underlying formulas. You'll investigate 3x3 all the way up to 7x7 magic squares. Basically, you're going to pull back the curtain on the magician and learn exactly how to construct and deconstruct these incredible numerical structures for yourself. How cool is that?
Chapter 4, Powerful Modular Arithmetic Applications. If you've ever wondered what makes modern cryptography actually work, well, this is your engine room. It relies on congruence, which is a relationship showing that two numbers have the exact same remainder when divided by a specific modulus. The easiest way to think about it is like clock math. You know, when you pass 12 o'clock, you don't go to 13, you cycle right back to 1. You're going to master modular numbers up to mod 12. You'll learn the formulas to determine sums, differences, and products involving these modular numbers, and you'll investigate non-routine problems that train your brain to think cyclically instead of just linearly. It's an incredibly powerful tool for real-world problem solving.
Getting into Chapter 5, Euclid's algorithm and Diophantine.
All right, it is time to bring out the heavy analytical tools and systematically conquer some seriously intimidating equations. Your battle plan breaks down into 3 simple steps. First, apply the division theorem. Second, execute Euclid's algorithm. And third, utilize Bezout's identity. By providing clear, logical justifications, you'll critically assess solutions to basic linear Diophantine equations with 2 variables. I know, that sounds incredibly complex, but this course actually breaks it down into a highly structured step-by-step process. You'll learn to confidently assess solutions for both routine and totally non-routine problems. You are quite literally gaining intellectual superpowers here.
And finally, Chapter 6, Unraveling Irrational Number Mysteries.
So, you've mastered the integers, the primes, the algorithms. Now, we step into the infinite. Just consider the contrast for a second. Rational numbers are orderly fractions, neatly simplified using a greatest common denominator. They make sense. But irrational numbers? They are infinite and completely chaotic. We're going to dive into complex fractions, continued fractions, and the special cases of irrational numbers that completely defy simple logic. You'll conceptually contrast these 2 worlds, assessing solutions that bridge the gap between order and absolute infinity.
Now, to ground this cinematic journey for a moment, let's talk about the actual MTES6012 assessment, which is highly structured and really rewarding. 60% is continuous assessment. This includes 2 quizzes and a 1,600-word analytical report where you actually go out and identify these patterns and underlying principles in your daily life. The remaining 40% is your final examination. It's a really perfect balance, making sure that your consistent, focused learning is rewarded just as much as your final comprehension of the grand concepts.
The foundational mysteries, the hidden codes of primes, the magic squares, the cyclical power of modular arithmetic, the heavy tools of Euclid, and the infinite chaos of irrational numbers. They are all waiting for you in MTES6012. The blueprint of reality is sitting right in front of you, but it requires a key. So the question is, are you ready to unlock the infinite? The sequence has already started. Enroll, and let's see just how deep the code really goes.